So I'm going to show you how to do the proportion hypothesis testing for the final exam, where you can use the SALT feature and it'll make it a lot easier. You can't do it for the ones that have the population standard deviation. So let me show you how quickly you can do it for the proportion ones. So I'm looking at question 33. In a survey of 781 U.S. adults with children conducted in 2009 by the Financial Industry Regulatory Authority, 294 said they had saved money for their children's college education. Could you conclude that more than 33% of U.S. adults with children have saved money for college? Use the 0.5 level of significance. Find the P and state the conclusion. All right, so first thing you got to do, let's put this in steps. First, number one, make hypotheses. Okay, remember, I'm going to use the P because it says, can you conclude that more than 33%? So that means I'm using the P for a proportion, and I'm going to convert this 33% to a decimal. So remember, the null always has the equal sign in it. So the null is P equals 0.33. And again, can you conclude more than 33%? So this is where I'm going to use the greater than symbol in the alternative. So those are my hypotheses. All right. Next thing I need to do is I need to go to SALT and put stuff in here. The important things is I have 781 right here, and then I have 294, and I have my level of significance, okay? So if I go to SALT, we go to SALT. All right, so what I'm going to do is I'm going to go here to inferential statistics, do one sample proportion. The number of successes is going to be your lower number, so that's 294. Number of trials is the larger number, so that's going to be 781. All right, I'm going to pick hypothesis testing, and then I'm going to put the hypothesized proportion, and I'm getting that from here in my hypotheses. So I put 0.33, and then I'm going to do the greater than because that's the alternative hypothesis. And then I hit generate results. And here, and you can see, make sure they're the same. These are exactly the same as my hypotheses right here. And then I'm going to take my p-value. So my p-value is, oops, let me do this. So, okay, number 2 is enter the statistics into SALT or the calculator, if you want to use the calculator. Okay, so number 2, I got my p-value. Oops, so p-value is that. Okay, and I think, oops, I want to go up. It's being pissy. P-value equals, and it wants the p-value, I think it wants it in 4 decimal places, so it'll be 0.0029. Okay, so that's my p-value. All right, I'm not done yet. So what I need to do is I need to compare the p-value to the level of significance. Okay, so 0.0029, and then I have, let me move this all the way so you can see it better. Come on, move that way. Okay, it's going to be 0.05. All right, if the decimals are throwing you off, do yourself a favor. This is 4 decimal places. I'm going to add zeros here to make this 4 decimal places. So now I can compare it. So if I look at 29 compared to 500, I know this is, and I'm going to insert the correct thing, less than or equal to that. So I reject the null, the HO, okay? So this means I reject this hypothesis, and I'm going to keep this hypothesis, okay? All right, so what does it want me to do? All right, so I found my p-value. So what it's telling me is because I kept my hypotheses, so now I'm going to conclude it, okay? So the last thing is I'm going to conclude it. And I know that the proportion is greater than 33%, okay? So I've got the correct p-value. So Here's where it gets weird, okay? And I'm gonna do this. I'm gonna get rid of all the other p-values because you figured out what the p-value is, and that's good. Let's get rid of this. Let's delete the entire rows on these, okay? All right. All right, so I have my p-value here. They all look wrong. They have the X is because I just needed the answer, so I didn't take the exam. All right, so remember I said concluded. Say I'm keeping this, okay? I'm gonna keep this hypothesis. I'm gonna put it here, right here. Okay, I'm keeping that one. So which one of these means I'm keeping it? Okay. All right, so it's saying the first one says there's not enough evidence to conclude it's more than 33%, and that's not correct. So it's this one. There is enough evidence to conclude that more than 33% have saved money for college. Okay, because it actually helps me here. I'm going to get rid of that X so you don't get confused. Come on. Okay, it's just being difficult. We're going to. All right, never mind. I was trying to be nice, but it's being weird. So this is the correct answer. There is enough evidence to conclude that more than 33% have saved money for college. And because of why? Because I concluded my alternative was true and the proportion was greater than 0.33 or 33%. All right, let's do a different one. So, oops, and you can see the p-value, but let's shove it anyway. All right, I'm going to go back up here. I'm going to get my steps again, and I'm just going to fill them in because it's going to make it easier on me, okay? And if you want to, I would say keep the steps. Okay, first step, make the hypothesis. Well, let's go read the problem. A popular blog reports that 60% of college students log into Facebook on a daily basis. All right, I'm going to do 60% of college students. The dean of students at a certain university thinks that the proportion may be different at their university. Okay, different. Didn't say less than or greater than. So she pulls a simple random sample of 205 students and 113 report that they log into Facebook. Okay? Can you conclude that the proportion of students who log into Facebook differs from the 0.6%? Use a 5% level of significance. Okay, I have everything I need, okay? So I'm going to go down here, make my hypotheses. Again, I'm going to use the proportion symbol, but now I'm going to change this to 60. All right, let me get rid of this because now this is changing. And I'm going to do this. Okay, so what sign needs to go here? Differs. That doesn't mean less than, that doesn't mean greater than, that just means different. Okay, so I need to go to my symbols and it's going to be not equal. So not equal to 0.60. So those are my hypotheses, all right? So I need to go to salt and I need to enter my stuff, okay? So I'm going to go back to salt and I'm going to do this. She said, how many did she say? So 134 out of the 205, okay? And she said it was 60%, and she said it was not equal to. So then I hit generate results, and look, if you look at my null and my alternative, they're the exact same of what I had here, okay? So then my p-value for this, let's go here. Oops. Bring it back over. Okay, my p-value is, let's see if it'll go in here. It probably won't. Is 0.1168. Okay, so that's my p-value, and it's good. Okay, so now I need to compare my p-value, which is 0.11168, and I need to compare it to my level of significance. Remember, in the last problem, I just added these extra zeros because this is my level of significance, and if I want to compare them, all I have to do is add zeros to make this 4 decimal places equal this 4 decimal places. Okay, so if I'm going to compare 0.1168 to 0.0500, this is greater than, okay? So because this is greater than this, I fail to reject the null hypothesis, okay? So that means I'm going to keep the null and I'm going to reject the alternative, okay? So what can I conclude is I'm going to keep the null, okay? I'm going to conclude it, all right? But now what do I need to do? Okay, so it wasn't different. Okay, so she was incorrect. Because remember, she said it was different. And this, if I kept my alternative, that would mean it was different. Because it wasn't different, then it's the same, all right? So I'm going to conclude it. So again, my p-value was good. Let me get rid of all these other extra p-values because now I have it. Okay. So how am I concluding it? There wasn't enough evidence to conclude that the proportion was different, okay? And why did I do that? Is because, remember, she said it was different, but when I failed to reject the null, it meant that the proportion was really 0.60, so she was incorrect, okay? So that's how you do that one for that one. Okay, let's do the last one together. Okay, I'm going to skip this one because it's a mean, and let's go here to 37. All right. In a survey of 78, okay, this is the same. Is this the same one that we just did? I think it might be. Oops. Well, let's go back down. I think this might be the same. Yeah, it's the exact same. Okay, so number, whatever this one is the same as the other one. So I'm not going to do it again because it's more than. So I don't need to do that one again. So number 37 is the same as the one we did before. Okay. So I'm just going to mark this one out because we already did that one. Okay. All right. And those are how you do the proportion ones. I think that was it. All right. Why is it being weird? My freaking thing is just being really weird. So let me see. I think that was it. 37. Yep. We're good. Okay. So I'm going to stop it now.